Hello and welcome to Natural Bliss Podcast for a better quality of life. I am your host, Joyce Wheeler, and we have a special podcast today. You might notice that the sound is a little bit off. I forgot to turn on my microphone, my microphone. So anyhow, go over to heavenlybodieswellness.com. We're having a Valentine special, 20% off site-wide. Use coupon code SHARELOVE, all capitals, or you can go ahead and get a gift card. So today I have with me Randy Wheeler, and we've got like I said, we have a special podcast for you. So here we go.
Welcome to the show.
Hello, everybody. How are you doing? We've had a lot of questions lately about. Is that better? Do we want to start over?
No.
I had about 4 years of electronic schools. Started off in high school, actually, which would actually increase it to more like 6 years of electronic schools. But they had a very good electronics course there, and then I went on to the area vocational school where I learned quite a bit more. And then eventually I decided I may want to go into engineering. And I had computer engineering for almost 2 years. Wish I would have finished it, I never did. But anyway, I decided I liked the repair industry or repair part of it a lot better than I did the engineering part. And so I decided to go into the repair end of it. But I had some questions lately from people about explaining how things shield, and it's difficult if you don't understand the theory behind it. I had some people in the past. I used to teach a class in sound reinforcement fundamentals, and I had some guys, because I've done electronic repair on musical instruments for years and years, and I did a lot of tube amplifiers. And I've had guys that said, well, I'd kind of like to learn how to, repair some of this stuff and repair some of the tube amplifiers myself. And there are some things that you can do as a layman yourself. You want to be very careful because you're reaching your hands into very high voltage. So there's a lot of safety things that you definitely need to learn before you try starting any of that. But being able to attempt to repair an electronics without understanding the theory is kind of like being able to drive a car without being able to read road signs. You can get there, but you're going to have to stop along the way and ask a lot of directions. And explaining shielding, if you don't understand the theory behind it, can be very difficult. You can't take a picture of a radio frequency moving through the air. And so I can't really show you a lot of the things that are happening. But I think, give you some demonstrations, some very basic shielding. But to understand how much you really need to know to get a good understanding of shielding, this is the book that I started with in electronics at the area vocational school. It's just called Electronic Communication, written by a man by the name of Robert L. Schrader. And if you look where I am here, I'm about in the middle of the book. And that's the first time that the book ever mentions anything about shielding. There's a lot of theory and a lot of things that go on that you have to learn back here before you ever even get to that part. And when we do get to this part, it's very basic. So that gives you an idea of how much you really need to understand before you're going to have a really good understanding of exactly what's happening in electronics. Shielding can be very simple or it can be very complex. An example of this is my electric guitar, one of my guitars that I've got. And recently I had a problem with it where you plug it in and it goes to the amplifier, this little jack, there's a little jack around here, it's hard to see in the dark, but it had come loose. And I guess just out of laziness, I didn't stop long enough to tighten it up. Well, from the process of plugging it in and out several times and moving things around, I broke the wire loose. So once I broke the wire loose, I was forced to go in and fix it. So I pulled it loose and I pulled the back off the guitar to make sure that I had enough room to pull the cable out without damaging anything. And I did my repair. Well, when I put it back together, And this is the back right here. I had put the back on it, and I said, man, guitar has a lot more noise than what it had. And so I pulled the back off of it, and I realized on the back of this thing is just a little bit of basically aluminum foil like you would use in cooking in your kitchen. And aluminum will act as an electronic shield. And so what they did when they manufactured this guitar is they took a little strip of aluminum and connected it to the ground down here on a component. And then that strip came up, and when you would put the back on, this aluminum on the back would come in contact with the aluminum down here and would complete the grounding circuit. And so that would shield out some of the external noises from the guitar. And when that was not making, the guitar was noisier. Once I repaired that, the guitar was not near as noisy. So that's how simple shielding can be. Shielding can be a lot more complex than that. But here, another simple shield can be just, can be right here. A lighter and a little piece of plastic. So if I light the lighter and I stick the flame right up against my hand, I'm going to get burned. But if I take this little piece of plastic and I light the lighter, I can stick the lighter basically right up to me without getting burned. If I hold it there, the heat eventually is going to pass through and will start getting hot to my hand. But this will decrease the amount of heat that my hand is getting. And that's what we're trying to do, is decrease the amount of all this electrical noise, we're going to call it, in the air today. And how much is there in the air? That's another question. Well, how much do we really have that we're trying to compete with? Well, I'm going to show you a little slide here. And let's see. I'm going to get my computer. Do we have that? I'm sorry. Where I can share this? Ah, there we go. Ah, there we go. This is a United States frequency allocation chart that shows all of the frequencies that we're using. And it goes all the way up to 300 megahertz, which is way up there. It's down well below the AM radio band, which starts around 56,000 cycles, all the way up to 300 gig. It's the entire spectrum. Well, when I was in school years ago, back in the 70s, all of this upper end stuff basically did not apply. There was nothing there. One reason why it didn't apply was simply because we didn't have the technology. There wasn't the technology to transmit on these bandwidths. And as time has gone on, of course, our electronic technology has grown greatly. But the important thing that I want to emphasize here is that all of this energy that is being put into the air is additive. If I have 1 watt and I add another watt to it, I now have 2 watts. Well, all of these energies individually are very, very small. They're way down in a very, very small amount of energy. But when you start adding all of them up, they start increasing and increasing and increasing. So the total amount of energy that we're exposed to in the air today is considerably larger than what it was years ago. And what do our bodies operate on? They operate on electrical impulses. When I tell my body, get my mouse here, tell my body to click the mouse, that's one electrical impulse right there. My body knows from my brain telling it to go down and hit that one button on the mouse. It doesn't tell it to do it on both hands. It only tells it to do it on one. And so it's very, very small electrical impulses. And there are things that can interfere with those electrical impulses. And so let me show you what I've got here. This is a book. And this is Lightning and Surge Protection, Grounding, Bonding, and Shielding Requirements for Facilities and Electronic Equipment from the Federal Transportation Administration. In other words, the Federal Aviation Administration. These are all the requirements in this book that are required for the grounding of all their equipment. because they have to protect from static charges such as lightning. They also have to protect their equipment from each piece of equipment. When you go to an airport and airplanes, you've got a lot of radio equipment that is operating. You've got transponders from aircraft that are coming into the airport. You've got communication between the pilot and the tower. You've got all kinds of systems that are running at an airport. So it's very important that they shield each individual parts from each other. And some of the shielding in that case becomes very complex. Now, if you were to try to if you just want to completely get away from all of this stuff, you would have to build a thing called the Faraday Cage. And a Faraday cage is actually quite complicated. It would include a lot of different types of metals that you would have to have shielding all the way around you that you could go into, but that's really not necessary. What we're trying to do is simply reduce the amount that we're exposed to, because it's like the lighter up against your hand. If you put the lighter right up against your hand, you're going to get burned from the flame. But if you can decrease that amount of heat by putting something in between, then you can keep yourself from getting burned and simply decrease the amount of heat that your skin is exposed to. We also have distance. The further that you can get from whatever radio frequency transmitter that you're close to, the less you're going to get. It has a definite amount that it decreases, which is called approximately 6 decibels every time you double the distance from the source, which is a big decrease every time you double the distance from whatever the source is. So the same is true as you get closer. As you get closer and closer and closer, we're increasing the amount that we have. Now, I got to show you that Shungite, and it's very difficult to do, will reflect and absorb certain energies. I got a bonus the other day, something I didn't expect to get. I recently had a fall. I was working in my greenhouse and I broke my collarbone. And so it's been in about a month, and I had to go back to the doctor, and he wanted me to get an x-ray to see how things were healing. And so I took the x-ray, and so I had on my Shungite necklace that I've got here and a couple of other necklaces and didn't even think about it. And so they took the x-ray, and so I'm going to share that with you. This is me, and this is where I broke my collarbone. But if you look up here, right here, this is my Shungite necklace that I'm wearing right now. And I didn't expect this, but what that shows is that Shungite necklace will do 2 things. And I talked to the doctor about this. We both agreed that Shungite necklace is absorbing some of those x-rays, and it's also reflecting some of those x-rays. So in that part of my body where that Shungite necklace is, the amount of x-rays hitting my body was decreased. If you notice right here at the bone, where there's a bone there, you can't really see the bone. What you see is the Shungite necklace. And as it comes across here, you can see mainly what you can see is the Shungite necklace. So that was a little bonus that I just really didn't expect. And how do I get out of this? This. Here. Am I back?
X-ray stop.
Hmm?
The X-ray stop.
There we go. It didn't go away and I couldn't find it. Okay. Now, let's take a look at one thing to show you. This is a ohm meter, voltmeter. It's a what's called a DMN, a digital multimeter, so it will read several different things. Excuse me. Our bodies will conduct electricity, and that's a very simple thing to prove. If I take the meter and I put it on the ohm scale, which is there, what comes up in the display, it says OL. That stands for open leads, because the leads aren't touching anything. If I take the leads and I put them together, it shows me the resistance of the leads. And I've got something that's popped up on my computer here. There we go. Now I can see a little bit better. And can you see that?
Yes.
You can see that my lead resistance is approximately 0.3 ohms. It's very low. Now I'm going to take these leads and I'm just going to lay them across my skin. And you notice it went from open leads and all of a sudden it's getting a reading. And I can't exactly see what that says because I'm turned around opposite in the camera. Although when I checked it earlier, it was up in the mega ohms. And normally, like in the summertime, when my skin,
Like 10.2038, it's fluctuating.
yeah, it'll fluctuate. But you notice that there is something conducting there. So my body does conduct electricity, and the skin conducts electricity, and that's a very important part because things that conduct electricity is what shields us from external radio frequency sources. So our skin helps to block out some of the things from our body. So we're designed that way. We're designed to block some of those things out. In the wintertime, my skin reading is higher because my skin is a lot drier. Right now, we've had some very cold temperatures, and the relative humidity meter that I've got in the house is showing us down somewhere close to 35%, which is extremely low. All right, I want to show you a couple of things in the house. First thing, I've had questions about a microwave. Do we really get that much energy from a microwave? So I'm going to move over to the microwave, and we're going to take a look with my RF meter to see exactly what we get off of that. Okay. What I've got is my radio frequency. Okay, we're back again. Few little glitches. We're not professional video people, but I want you to take a look at my meter, and all of a sudden, for some reason, it's gone really high. Oh, you're holding the camera close, and it's got some things that it's doing. But if you look at the level around 254, 146 millivolts, actually 343, it starts beeping around 300. And I'm standing about 6 feet from the microwave. So what I'm going to do is I'm going to go turn the microwave on for about 45 seconds. I've got a bowl of water in it. So I'm going to come over here and go 45 and start it. Oh. Helps when you hit the right buttons. And if you look on the meter, it's jumped up to well over a volt. 819, 780, 855. So 2.4 volts, it's increased considerably. Well, I've got a Shungite blanket, or a Shungite pillow, I'm sorry. I'm just going to ease it over in front of the meter. And you notice it has dropped considerably. 346, 18.5, dropped way down. Matter of fact, it's not getting near as much red as what it did a minute ago. So I'm going to 240, 212. It's varying because there's several electronic sources. Then I'm going to pull it away, and it jumps right back up. Fortunately, the microwave turns off. Turn it back on. Nope, sorry. Get shot on the meter. And you notice this jumped way up. 800 and something, 700 and something millivolts, 600. When I put this in front of it, and we have definitely dropped way back down again. So the Shungite pillow is helping to block a considerable amount of that energy from the microwave. I pull it away, and we go back up there, it's shut back off again. But it does cut it about in half. Okay, we're going to make another move to the living room this time. Okay, what Joyce is showing you is a picture of our Wi-Fi box that we have here. And if she can turn the camera around this way and put it right on my meter, you can see, she can move over just a little bit. You can see about where my meter is, 315 volts, 430 volts. So I'm going to take the pillow and I'm going to put it right in front of it. Wow. That dropped the signal from the Wi-Fi way down. Move the pillow back out and it comes right back up. So does the Shungite help to shield the Wi-Fi? I would say definitely. Okay, pull it back away. And it's back up again. All right, let's go back to where we were. Okay, we're back to where we were. So you do see that the Shungite will help. And it anything, people, the big question nowadays has been about 5G and the extreme high frequencies of 5G with the millimeter wavelength technology. Well, actually, it's very easy to block 5G and the 5 millimeter wavelength technology. As a matter of fact, they're actually having more problems with it than they thought that they would. Are those waves damaging? Yes, they can be, because those very, very small millimeter wavelengths are getting down to the size that it will really affect our bodies. But they are having to incorporate that with some lower frequency stuff at this time. I think that maybe they didn't expect to. But anyway, they're having to make some changes. There's a lot that I don't know about it. What's really bad about the 5G is the complex data burst that's in them, kind of like with your smart meter. If I go out and I read the RF of my RF meter off the smart meter, most of the time I won't get anything. Smart meters come on, they do their data transfer, and basically they're back off again. They're not doing the data transfer all the time. But that data transfer, the big burst of this data, is what the modulation with the waveform is what appears to be the most dangerous part of it. But most of that also, we can block it. What we do is, and what I recommend, you saw the blanket that we held in front of it at the Wi-Fi router. Well, the shielding is best either close to either source. The source means whatever you're trying to shield, which in this case is our bodies, or closest to the transmitter. And so I didn't show on the Wi-Fi box that we have in there. Number one, we own our Wi-Fi box, and I can go into the parameters and turn the level down. I don't have my Wi-Fi box turned all the way up. When you look at our Wi-Fi, it's about strong enough to reach everything that's in the house. If you go outside the house, you do not get our Wi-Fi. And so that's one of the advantages of owning the Wi-Fi box. But also, we keep a big piece of Shungite right by the box, and where there's not as much coming directly off of people. And we also have Shungite Pyramids that we simply set on the end table beside us. I've got a big 250 milliliter, which is the largest pyramid to my knowledge that is available. Also, we wear the pendants and the different pieces, so the closer that you have them to you, the better. The necklace, which you saw in the x-ray, does help, reflect and absorb some of the energy. And what happens to that energy that is absorbed? This radio frequency energy in the air, it doesn't go away. If there's one basic thing that you learn in physics, is that energy cannot be created nor destroyed. It's only changed from one form of energy into another. Well, when those radio frequencies, when that X-ray was hitting my Shungite necklace, it actually is dissipated in the form of heat. But that X-ray is a very short period. It's just a little burst. And so you would never have felt any heat coming off of this. But all of the energy that is absorbed from these has to go somewhere. So it's dissipated in heat, just like all the radio frequencies that are hitting the earth. They hit the ground, and all that is dissipated in heat. So the energy has to go somewhere. It doesn't just go away. But the closer that you can have the reflective surface, the Shungite, to you or on you, the better it does job of shielding. So it's not a cure-all. There is no cure-all for this age. It's just like the 80,000 plus chemicals that we've got in our environment nowadays. We have to protect ourselves from it the best that we can. The same way, all of these radio frequency waves are here to stay. There's nothing that I know that we're going to be able to do to get rid of them. Plus, we're all very addicted to our phones and our computers and everything in your house. And that's another thing that's additive, is all of the sources that you have in your house. My computer in front of me, Joyce's computer over here. We have 2 printers in the room with us. We have 2 cell phones in the room with us. We have one of her kids that's still living with us, that he has a phone and a computer that's doing the Wi-Fi. All of these energies are additive. Now let's think about when we go on an airplane, to give you an idea. You have your phone on an airplane, and before you take off, what do they say? Put your phone on airplane mode or turn it off. And what I do is, I don't ride on an airplane that often. I love airplanes, but I turn my phone off, completely off. And the reason being, you always have one guy or one woman on there that's exempt from these things, and they don't want to turn theirs off. Is one phone on that plane going to affect the systems on that plane? Probably not. The phone isn't powerful enough to do that. But like I said, these things are additive. Think about if that flight has 150 people on it, and 100 of those people decided not to turn their cell phone off and decided to use them. Well, whatever that power level is, it just went up by 100. So you greatly increase the amount of energy now that is being transmitted to all of those systems on that aircraft. Do we really want for our cell phones to interfere with those systems on that aircraft? I want that aircraft to be able to do its job. That's what I want. So I'm very respectful of that. First thing I do when I get on an airplane, why do I need my phone? I don't. So I just shut it off and put it in my bag. So that's what I recommend to do with that. So anyway, I hope that this has been helpful. I'm sure I'm not all, I agree that I'm not always the best in explaining things, but if I have more time, a lot of times I can work on it. And that's what we want to do, is give you time. This Wednesday, which is February the 9th, we're going to take the time starting at 12 o'clock Central Standard Time to have a live session where we can take questions. And I hope that I can give you some honest and accurate answers. That's what we want to do. If you think of a question in the meantime, and maybe you've got to work or you've got to do something, you won't be able to be there for it, so but you can watch it later. You can send your questions to naturalblisspodcast@gmail.com in advance, and we'll work on the answer to something that will help you. Hopefully it's something that will be able to help you. And also just be able to learn a little bit more about these things. Now I'm not, there's other materials that shield. There's lead, there's copper, there's silver, pretty much anything that conducts electricity will shield. Shungite's not the only thing. But the thing about Shungite is it's a lot more attractive than having a big piece of lead sitting by your Wi-Fi unit. Your refrigerator, you can go stand in front of your refrigerator, put your refrigerator between you and your Wi-Fi unit. And of course, you may want to set a TV there too, because then you can watch TV with your refrigerator shielding you from your Wi-Fi unit. So there's a lot of things that you can do, but the Shungite, which comes in many sizes and many shapes, here's one of the pyramids, and I think this is one of the sizes that sits on Joyce's side over there when we sit at night. And we've got the tall pyramid that I have here that are available. And also we have the step pyramid, which I particularly like for shielding, because these little slices in between with the certain frequencies, they will cause what is called diffusing. They will break the signal up. And so these are particularly nice to have. And also the jewelry, which is like the necklace. And oh, I've got another one here. Here's one of the necklaces. I believe this is the same one as that I'm wearing. I think that's about a $20 piece. The blanket, like I showed you earlier. And we have things like the Merkaba. And we have wish stones that you hold, which I don't have in here. And this is a piece that I carry with me because of my job, which is just a flat plate. And I noticed an area that was real strong in radio frequency because I carried my meter with me one day. And I said, I might want to do something about this. So I took this and I set it right in that area where it was real strong. And I cut down by about 2/3 in the amount that my body was receiving. I'm not as sensitive to energy as a lot of other people out there are. I've worked in electronics all my life. I've been around a lot of different energy sources. Although I'm realizing now sometimes it did affect me more than what I realized. It goes back to the old saying, you can't find what you're not looking for. And I think I just didn't realize I wasn't looking for it at the time, and it did affect me some. But there are some people who are very sensitive to these energies. It causes them headaches and just all kinds of things. So for those people, if you have a question and I can help you with it, hopefully I can give you an answer and get you on the right track. So that's what we try to do. We're just trying to help people the best that we can. So anyway, if you have a question, send it in. If not, if you can make it to the live next Wednesday, do that. And so I thank you for listening, and y'all have a great day. Now I'm going to turn it back over to you, Joyce.
Thank you, Randy. That was very informative. For the link to sign up for the event will be in the description, or you go to the Natural Bliss podcast page on Facebook, and there is a link that will take you there also. So I hope you found this very informative. Enjoy the rest of your time of your day, whether it be morning, noon, or night. And thank you for watching, and keep shining your light.